because now the knowledge which is needed to use effectively the semi-random method and building a so-called absorbing configuration, now we have all the results, and of course, it not only combines them, we of course need new results. So that is an absolutely brilliant result. And to my opinion, this one shouldn't make a statement, but at least maybe one can be a little bit subjective, namely that for me, this is one of the greatest results in discrete mathematics in the last, let's say, 10 years. And then you can make your favorite statement about this result. But this really is a beautiful and extremely important result. But it is important that it's used the semi-random methods and also absolute configurations. Now, I guess it is time. Now, let's see the next. I can get into the details, but this now time to ask the audience whether now I went through the program which I wanted to mention without any scandalous mistake, I hope. But now I should really explain what the absorbing configurations are for different programs, and now it is your choice whether I should go into it or that's enough of me already. I mean, I spoke 1.5 hours, which is very unusual because my usual time that is in my contract is 40 minutes or maybe at least 1 hour. That is the longest lecture which I have ever given. And, I don't want to mention personal problems like I had in surgery also on the road. So it's just standing here for half an hour more would be very difficult for me, but don't be shy. Where I can suffer, you can see I have a tie, I have the it's obviously extremely uncomfortable, yes, but it is just a small suffering compared to giving the lecture. So now it is up to you whether we continue or I just shut up and you can ask questions. I am not the one who decides it.
We still have 10 minutes now, but you start 10 minutes later.
I started 10 minutes later. You are very precise there, but that was not my fault. To start 10 minutes later. So I already started my talk exactly on 10:30. Whereas actually I started 10 minutes later, this were fault of organizing committee. So don't give me back this 10 minutes. Actually, because actually it just made my situation much worse because I was so nervous. So that actually in these 10 minutes I almost collapsed. So, alright, but if you want, then I give you the. So I get 10 minutes. Ready for 5. Alright. Not the idea, just the configuration. And then if you really want, then in the extra 1.5 hour I prove one of the absorbing parts, but that will be really up to you. Now, absorbing configuration for Elzahar is simply this one, then these are complete. So you find in your graph under the conditions and the sum of upper case ni over 2 is bigger than yes. So the minimum is bigger than the sum of ni over 2 upper case and 2. Then you will find a complete how you say this case tree. Then you have 3 groups. All of them are of size log n, and then of course the 3 pi time. Then every 2 classes are connected. All of the crossing vertices are present. This is case 3T. I am not going to prove that how you find this configuration. But that actually will be because at the very end we will somehow massage the remaining point into this configuration. So that is why this is an absorbing configuration. For that you really have to follow the proof of the Elzahar's conjecture, and then we see that at the very end will be left out with a small number of vertices, and then you massage them into this configuration, which is a very nice configuration, yes? And for the three-packing problem, the absolute configuration is very simple. That we choose three sets randomly, M, B1 and B2, but so that their size is small. The smallest one is, so gamma is a small number, eta is even smaller, and these are just parameters. Then the size of n, constant times n, but very big small constant, gamma to the 3 times eta. That is n, and it is being chosen randomly. And B1 and B2 has the same size, all of them are pairwise disjoint, and then you see, don't remember it, gamma times eta, which is much bigger, gamma to the 3, yes, times eta, because gamma is small. Gamma to the 3 is much smaller. So D1 and D2 is much bigger set than n. So that is the absolute configuration, and again I cannot explain why we can use this absolute configuration. Actually, between these two sets we will build up one factor, kind of one factor, and then using Koenig's kind of argument, we will have a power to interchange edges which are outside and then finish the jump. But I cannot say anything more than that about it, unless if I give you the proof, or at least part of the proof. Now let's say, I hope it is 25. Now the absolute configuration for the that actually is the more interesting thing for the k-1 Hamilton problem. But let's now just concentrate on the three uniform, because for the three uniform hypergraphs, and this is nothing else, just a path. But this path has look only the green edges. You see, look only the green edges. So this is a permitted path, means that every three actually, you take this one, and this one, there is this edge also here. But I didn't want to draw the edge because then the picture wouldn't be perfect. So this actually would be the part of a square of a Hamiltonian cycle. This is not just a path, but I should have included also the edges between this one and this one, between this one and this one, and every set of 8, yes, because that was the definition of the